In the last video, I talked about one of the big problems I have with AWS LifeCycle Manager's integration with SSM, and that is the inability to snapshot a really large volume or an application that takes longer than 2 minutes to get into a clean state. And that's the case for a really large MySQL database that I need to snapshot in order to ensure that we can upgrade from 5.7 to 8.0. I need to ensure that when I launch a volume from that given snapshot, that the application can come up cleanly. And if I don't do a proper shutdown, that volume is in a dirty state, and it takes about 6 to 8 hours in order to get MySQL into a state that it is usable once it is done initiating the InnoDB table recovery process. So let's dive right on into the script and what my solution is here. And ironically, my solution is something that I did about 2 years ago, and I stopped doing because I wanted the convenience of Lifecycle Manager's automatic management of snapshot removal and just a third-party system outside of the cron process itself that could be responsible for ensuring timely execution of snapshots. I didn't want to have any potential of the process itself crashing. So in this video, let's dive right on into this. There's a couple of editable sections in here. So right at the top in this script, if you are copying this from the GitHub gist, check the link below, and you can follow along with this. The first command or first variable in here is do backup, and that is set to 0 by default. This will then, if you were to run the script with that not being updated to 1, it'll just say, hey, the script is not enabled for running the backup. And second, there's we need to set the username, the host name, and the password in order to execute MySQL commands against. Next in here is the EBS attachment volume name. In EBS, there are volume names. They typically are like /dev/SDF through Z in there when you add a new volume to an instance. However, inside of the operating system, you'll often see that as like /dev/NVMe 0n1 or 1n1. So there's a little bit of a misalignment here, but you'll need to check in the AWS console what the volume is that you're using for your application that needs. Going down further, I have the project and environment. This is where getting tags from the instance. So tag your MySQL instance in question here in order to get the snapshot labeled correctly in the snapshots interface in AWS. And that's also useful if you want to say launch snapshots, if you're doing like a nightly build of a database. So if you want to say take the production database and then have the develop database built nightly from that production, you can then leverage that snapshot in your other scripts elsewhere. We just set those variables there, combining the project environment as the name in there. Going down a little further, we just figure out what volume we need to snapshot, and then we dive into a couple of sections here. So first of all, I wait for slave synchronization. So I want to make sure that from the point that I trigger this snapshot, that this instance is fully caught up with whatever changes are going on in the production database. And we just wait until this gets to 0 seconds behind master, ensuring that it is at least caught up. And depending on how far behind your replica might be behind production, you could expect some variability in here. I like to do this just because I want to make sure that whenever I snapshot this, that this is in fact truly up to date. So if you're setting downtimes or paged events, make sure you adjust accordingly and make sure you have a big enough downtime window to account for variability in your application. At that point in time, once it's all caught up, then we say stop MySQL, and then that's a blocking operation. It waits for MySQL to come down. Once that's done, then we request the EBS snapshot. There's one more function here that's relevant, which is the wait for EBS snapshot creation to complete. And this one, I decide whether or not I want it to do that or not. It's totally unnecessary, frankly. As soon as EBS gets the trigger to say, hey, create a snapshot from this volume, as long as you get a snapshot ID back and it's in a pending state, then you should be good to go, and the volume is already quiesced and it should be able to handle subsequent write activity. Now, if you're looking at your script going down, you'll notice I have a start MySQL and a start slave. That's because by default on our replicas, I have skip slave start to be true, And that's because when we start up an instance from a snapshot, we need to clear the server ID. And I think there's an auto.cnf, which also has to do with launching an instance and getting it caught up with the rest of them. If you don't clear those out, you could have a conflict where you're launching a new MySQL replica, and then a currently running MySQL replica will be like, whoa, hold on, a transaction's already executed that on another instance. So that's just a process you'll need to know when you're launching up a new volume. And then we have this trap handler and this finish command. So the idea that I have here is that even if the EBS snapshot process fails or stopping MySQL fails, I want to make sure that we always execute restarting MySQL and restarting replication. And that is just so that the script executes in a safe manner, or I should say it has a fail-safe. So if anything preceding breaks, we don't screw up MySQL itself and then have a non-replicating replica. And that's that script in a nutshell. In subsequent videos here, I'm going to dive into the missing components that we have in order to replace our lifecycle manager capability. And that is ensuring timeliness of backups. And then secondly, that we clean up backups. So that's the other side of things. So this will create lots of snapshots, but now we need to make sure we delete old snapshots so we're not holding on to old data that is no longer useful for our recovery window. So that'll be a separate script that's executed elsewhere. And then you will have a functionally equivalent lifecycle manager plus SSM set of capabilities in order to manage your backups for a really large MySQL database. I hope you found this useful, and go ahead and let me know if you have any questions, comments, or concerns in this video. I'd love to hear how you're handling backing up really large self-managed MySQL databases. Anyways, thanks so much.